Hello everyone, welcome to Ashnik's Postgres Google Hangout session. I am Sakshi from Ashnik. With me, I have Samir Kumar, who will be running today's session. Samir is a senior solution architect with Ashnik. Let me quickly tell you about us. Ashnik is an enterprise open source solution provider headquartered in Singapore with presence across Southeast Asia, India, and the US. We provide PostgreSQL based solutions and services and have enabled over 100 enterprises to adopt open source technologies successfully across these regions. In today's Hangout, we will be talking about some of the reasons why you should consider applying a Postgres patch promptly and the best practices and procedures that can help you achieve near zero downtime patching for Postgres. If you have any questions regarding today's topic, please type it in the chat window and we will be answering all the questions at the end of the session. Over to you, Samir. Let's begin.
Thanks, Sakshi. Thanks a lot. So, hello everyone, and let me share my screen, and then we can start with our presentation. And okay, so we will be discussing about near zero downtime patching for PostgreSQL. But before we start, let me talk about PostgreSQL versioning so that everyone here is a bit familiar with the versioning system in PostgreSQL. Until 9.6, PostgreSQL had the form x.y to represent major versions. That means 8.4, 9.0, 9.1, 9.6, all these are the major versions. Changes between major versions are not backward compatible. That means you just cannot copy the data directory of version 9.1 and run it as it is in 9.2. These major versions usually come with heavy optimization in terms of performance, enhancements in terms of features, and a lot of new features as well. The next version, which is version 10, is going to include a lot of great features, a lot of enhancements, especially on parallel query, and a lot of performance optimization as well. Some of the important features coming up in version 10 are logical replication, parallel query enhancements, and better syntax for partitioning. So if you have not liked the partitioning implementation of PostgreSQL so far, there is something great coming up for you in version 10. Minor releases are numbered as the last part of your version system. So if your version has been set up, is displayed as 9.6.1, 9.6 will be the major version and .1 is the minor version or the bug fix on top of GA release. Similarly, you have other releases will also have their own latest minor version available. These patches or these minor releases includes bug fixes and security fixes. And typically there would be a drop-in replacement for the binaries, and there is no change in the data format or in the on-disk block formats. Please note that the versioning is going to change in version 10 onwards, and from version 10 onwards, PostgreSQL community will follow one number format for major version. That means you will not see 10.1 being the next major version. The next major version would be probably 11, version 11. And minor versions will be the second digit, or sorry, the digit after the decimal. That means 10.1 would be a minor release. If you have any application or any tool or any scripts which is dependent on the current format of versioning, you need to go back and probably relook at those scripts. Applying minor patches is highly recommended, and it basically helps you keep the database healthy and maintain the uptime of your database services. And that is what we are going to discuss in today's Hangout. Patching has some risks because you are going to apply libraries, you need to do all the testing, you need to take your application through the regression suite, and you will also have to have some kind of downtime because applying the minor patch would need a restart. And this is typically like a maintenance in your house, like you have got a broken wall, or there are patches coming off your roof or your walls. But the challenge is, if you don't apply patches, it is going to cause an even more severe problem, because these patches or these bug fixes or minor releases, they contain critical bug fixes. And if you don't consume them, if you don't apply them, you will eventually run into some sort of problem. And that is an unforeseen situation. It is like you're gambling with dice. You don't know when that issue will click and when that will turn into a problem for you. And you know it only when you're hit by a problem. You know it only when that bug has actually hit you. Now, this causes unplanned and longer downtimes, not like the downtime which you would have had while patching, because in that situation you will have a planned downtime. But when you're doing when you have skipped patching and you're hit by a bug, you usually run into a problem, and that problem causes an unplanned downtime. Sometimes it might lead to data corruption as well. We have had a customer who was using version 9.3.3 of PostgreSQL, and they had not applied any patch after going live. One fine day, what happened is they were not able to access 3 of their critical tables. When they tried to investigate, it turned out PostgreSQL log was continuously throwing an error in the logs saying that block number 1540 or XYZ is not accessible. And that turned out to be the block number or the page number which was relevant for the data that they were trying to access. Eventually, they had to truncate that table and load the data in those tables from the previous day's backup, and then take a full backup and do an upgrade of their database from 9.3.3. Similarly, we recently had a customer running on 9.5. I can't recall the exact version, but they run into one of the issues causing some kind of auto vacuum issue for them. And they also had to restore from a backup of previous day, and then they had to apply all transactions manually, perform those transactions. So I'm not talking about applying the transaction log, but manually they had to perform the business transactions and insert data from the backend systems. So you can have potential data corruption or loss of data because of the bugs which are there in an older patch or older version of Postgres. Sometimes these older versions will also have some kind of security threat or security issue which has been fixed in one of the next versions. So if you're not applying patches, you're actually sitting on a ticking timer, and which can explode anytime, which can unearth some kind of problems in your environment anytime when you hit that bug. The minor versions usually have data corruption fixes, like issues with MVCC. There have been very major issues in past which have been fixed in these minor releases, or issues with index corruption, or issues of block corruption. They also contain fixes for replication issues. There have been issues in past when you have a master, you have a standby, and data is being replicated from master to standby. But when you query data on standby, you get different results. Or when you do a switchover, The standby starts behaving abnormally. It starts throwing primary key violation issues, whereas the data has actually been already deleted. And all these issues are somewhere related to streaming replication or MVCC. Sometimes you also face issues with corruption of data on replica. So these are very peculiar replication related issues. And all these three kind of issues, be it data corruption or issues related to replication or issues related to security, all these are fixed as part of minor releases. So like I said, security issues as well are fixed as part of minor releases. If you remember OpenSSL Heartbleed bug, as soon as OpenSSL community came out with the fix for Heartbleed bug, PostgreSQL community consumed it and released a patch within the same day, which was consuming basically that new fix. So if you have an upstream, if PostgreSQL upstream components are being fixed, these minor releases will also provide a patch for that. Now let's talk about how to go about planning a patch and performing that patching. Typically, you should keep your patching window during your off-peak hours. You would not want to keep your patching hours around the time when most of the users would be using your database, because of course there would be some slight intervention, some slight disruption to the services, and you don't want that to be happening like 2 p.m. in the afternoon when all the users are using the system and there is heavy load going on. Typically, you would want to do that when you have least amount of load or when you can afford some downtime. Make sure that you read the release notes. Now, mostly there is a very standard way of applying the patch. You should apply the patch and restart your database, and you should apply the patch only on the standby databases first and then on the master databases. But there can be situations when you have some very peculiar steps to be followed, and that can be specifically true in case of a fix which is going to fix a potential data corruption bug or a potential replication issue bug. In those cases, you might have to perform some extra steps. You might have to at times rebuild your database or rebuild your standby. Make sure that you have read the release notes properly and you have tried to follow the instructions that have been provided in the release notes. Make sure that you test again and again on all the different aspects. Make sure that you have tested the patching process. You have tested the patch itself, that after applying that patch on your database, everything works fine. Make sure that your application has been tested with this new patch. At least the usual test cases have all been cleared. Run a round of regression, run a round of automation test suite of your application, and make sure that everything is running fine. And only then proceed to production. Do not go ahead and put your patch directly in the production. This again brings up a very important fact that some people, they treat the database as a data store and they only have one environment. They create different databases or different schemas to separate test environments for application from the production environment for the same application. While this ensures that you're able to patch your application properly, but at the same time, this does not ensure that you have a database set up which allows you to test your patches in a non-prod environment. So while it is very important for you to have a non-prod environment or a UAT environment for your application, you should have a separate setup exactly same as your production environment for your databases as well, where you would be testing these patches, where you would be pointing your application and testing after applying these patches and upgrades. Make sure you have a fallback plan. Ensure that if things go wrong, you have some way of way of going around it. So let's say if the patch does not work for you, or if a lot of your test cases are failing after applying this patch, how do you go back to the old version? How do you mitigate the risks around those? Of course, the first thing about it is that you should have tested that patch very well in your non-prod or UAT environment. But at the same time, if that goes wrong because of maybe the production load or maybe some peculiar test cases or peculiar data set in your production environment, if something goes specifically wrong after applying the patch in the production, you should have a fallback plan. Now let's talk about how you can minimize the downtime while doing the patching. Of course, you need some kind of high availability. You need redundancy in your system, and you should have a mechanism to avoid reconfiguration of application, for which you might want to use virtual IP, or you might want to use database middleware like PG Pool, PG Bouncer, or you might want to handle that at your client or application level. And you should be able to do auto switching or auto promotion of standby. If that is not happening, then you might have to do a lot of things manually, and then that again increases the downtime. So you would have a setup where you have a node 1 and node 2, and in that you will have replication slots set up so that when you shut down your standby, your master is going to retain all the wall files. And when you are going to apply a patch, you will apply that first on the standby. Now, like I said, the minor versions do not change the format of data and wall files, but there could be some changes. But all the patches would ensure that the standby is always be able to consume wall files which are produced by an older version. So that's why it is always important to apply patch on the standby first and then on the master. So we will now start with our demo. Before I start with the demo, I would like to walk you guys through the process that we will be following in this demo. In this demo, we have a master standby setup. On node 1, we have 9.5.0 installed, and on node 2, also I have got 9.5.0. I'll be trying to apply a patch which is 9.5.12, I believe. We'll check in a while. Now, I'm going to use EFM, which is Enterprise DB's failover manager, to perform automated failovers and also to manage virtual IP. You can use any other replication or any other database middleware tool as well. But I like EDB failover manager. It is pretty stable, and I have used it in production as well. So I'm more comfortable using it for this demo. We will start with a setup where we have 9.5.x or 9.5.0 in our case installed on both the nodes. And we would want to reach a setup where we have got 9.5.12, the latest patch for 9.5 installed on both the nodes. In this process, we might reverse the direction of replication. We might switch the roles of both the nodes. But if you want to revert back to the old configuration, all you have to do is perform a switchover again. For this diagrams, for you to understand these diagrams, the gray cuboid, the gray box represents node number 2, and the blue box represents node number 1. I would be more comfortable referring to them as node 1 and node 2, and I would suggest that you guys also in your production environments, especially if it is a HA setup, refer to the setup as server 1, server 2, or node 1, node 2, because in an HA setup you will have both these nodes equally capable of being the primary, and that's why I refer to them as node 1 and node 2. The dark red cylinder would represent a master database, and master database can be on node 1 or can be on node 2 depending on my current status of replication. I've used a, a thick arrow to represent streaming replication, and while I'm going to explain this process, you would see there are some steps which involves a shutdown database, and that is being represented as a gray cylinder. Now, before you begin, or before I'm going to begin, I would be checking that wall keep segments is high enough. This will ensure that while I'm performing the failovers, while I'm changing the roles of servers, the wall keep segment is high enough so that I'm not going to lose any changes which are happening on the master while one of the servers is shut down. Now, while you're going to force wall keep segments to be high enough, and you will also be using replication slots, you have to ensure that you have enough disk space on pgx log. I would say that for a low to medium sized database, 20 GB would be decent enough size for hosting pgx log. And ensure that your archive directory also has enough amount of wall files and it is not filling up. Now, another thing which is about risk mitigation would be to ensure that you have got installer for both the versions. So I have an installer for 9.5.0 and also for 9.5.12. So let me show you guys. Let me change the appearance quickly so that you all can view. Okay. I'm using, like I said, I'm using EDB failover manager. And this is the current status of my cluster. I have got a standby node which is on 145. I have got a master which is on 144. This is my master database. And it is currently running 9.5.0, as you can see. Let me change the appearance very quickly. And this is my standby database. As you can see, this is also running 9.5.0. Now, let me log into root and let me show you that I have the installer for both the versions available. So not 9.5.12, but 9.5.7 is the latest release. I confused it perhaps with 9.4. 9.4 is the latest patch for 9.4 is 9.4.12. So I've got the latest version as well as the version which I'm currently running. I've got installer for both of them, and that is what I mentioned here, that make sure that you have got installer for both versions. Now, the first step that I'm going to perform now is shut down the standby DB. So let me go here and let me say EDC, systemctl stop PostgreSQL -9.5. I've stopped my database, and now I'm going to apply the patch over here. This patch is just a drop-in replacement. So once I shut down, I'm applying the patch now on this server. While this patch is being applied, there is a slot called DB server 2. I have got a replication slot called DB server 2, which is maintaining the last wall file which has been transmitted to the standby, and it is going to maintain all the wall files which are created after that. So let me go back to my standby. Yes, I want to finish this installation, and it is going to do the installation now completely. And while this is being applied, any application which is connected to my database can still be connected on my primary DB. Let me show you. This is my primary DB. Right. So let me create a table here while doing patching. Patch level varchar. So I've inserted data into my table test patching on the primary. So let's say this is some data that has been created by your application. And once I've got my database system up, let me check the status. Postgres is running now. Now on the standby, let me select star from patching, and I have got version 9.5 copied here because this was something that I created from the from node 1. Right now, all I need to do is I need to add this node back to the cluster. Let me go to the status page and check. So in EFM, I have got one node which is idle right now, and its status is unknown because the database was shut down for a while, and after that, standby agent has not been listening. So all I need to do is I need to use EFM resume. Okay, not authorized. I'm running as Postgres user. So let me connect as EFM. And now things should be back to, yeah. So now my standby database is being shown as up again. If you notice, previously the status of standby was unknown, which is on node 145. And now the status is up once again. My cluster is healthy, and standby database is in sync with the primary, and it is safe to promote my standby database. So what I'm going to do now is I'm going to go to my primary, and I'm going to say systemctl stop the database here. Now I should be checking everything before I do that. Before I go ahead, I should go and I should confirm that my database has been upgraded properly. I've checked the recovery status. which looks fine. Now, what I'm going to do is I'm going to stop the database on my primary as soon as I've not used the right service. So as soon as I stop this, a standby should get promoted in a while. Looks like it has not stopped. It has not stopped, so I'm going to use instead pgctl stop command with fast option. Let me check status here. Okay, and so EFM, and then okay. I perhaps have an issue with my config file, I guess, which I did not configure properly, but never mind. I've managed to get my database up here. Once my standby has been promoted, I can stop the database, the stand on the master, and I can apply the patch here. Okay. So all I've done right now is I've shut down my master database and my standby has been promoted as master. Now this node is acting as the new master. I was accidentally going to apply the patch on the same node once again. Now, once that is done, as you noted, I was checking the status, and once it has been upgraded, I can go ahead and apply the patch on the master. So I can become root and apply the patch. The patch is over here. But before I do that, I need to ensure that while this master is down, I will have all the changes retained on this on the new master. And for that, I need to log in into my new master, which is node 2 or DB server 2. And over here, I need to say create PG replication, physical replication slot. And I'm going to name it DB server 1 because it is for DB server 1. Sorry. function. It's not a command. I always seem to confuse with that. So yeah, I've got my physical replication slot up now. Now that means that any change which is happening on my master, on the newly promoted master, will be retained, and all those vol files will be available to be replicated to the old master, or whenever it is upgraded, or whenever it is recovered after patching. So let me do one thing. Let me try to insert into test patching. Now I have got one row which is 9.5.7, and this is being produced by using the node 145, as you can see. And if your application is there, it can continue to talk by using this virtual IP. This is a virtual IP which is attached to the newly promoted master now. Now let us go back over here and apply the patch. Now once the patch is applied, I need to create a recovery.conf on the old master, which will be added now as standby. And that is the reason why I need to add recovery.conf. But you might sometimes just miss to add recovery.conf. And that is why, let me just show you. That is why as soon as the database is shut down, a recovery.conf is added, a dummy recovery.conf is added by your failover manager. So let me add a proper recovery.conf. This is node 144. I usually have, I have a sample recovery configuration here, which I have added. Now let me apply the patch. Patch is being applied now. Once the patch is applied, I need to check the cluster status with EFM, and I need to apply. I need to check the replication status. I need to check the recovery status on both the nodes, and whatever changes I will be doing on node 2 should be replicated to node 1, because I have reversed the direction of replication. And I'm using virtual IP, so node 2 should have that virtual IP now, like you can see here right now. Node 2 has the virtual IP. Now the patching has completed, and I can log into PostgreSQL. So the database is in recovery. That means this is acting as a standby now. I missed the from. The replication is not working right now. Perhaps because of some issue in the replication configuration here. Okay, I need to change my recovery.conf, I think, because yeah, it is trying to connect to itself, which is kind of not thing you want to do right now. Yeah, so now it should work. Okay, so let me use systemctl start. to restart the server. And now I think the replication is working fine now. So as you can see, the replication is working fine, and any changes which had happened on the new master should be available now on the master as well. Sorry, on the node that I have added as standby now. So node 1 and node 2 both have been upgraded now. And all I need to do now is assume the EFM status, and you can see that now EFM is running on, is monitoring all three nodes, last one being the witness, which is not a data node. But master and standby both are up and healthy, and they both have been upgraded now. So let us check the version here as well, just to be sure, because we checked it anyways, but one more time. Yeah. So the database has been upgraded, and the replication order has been also brought in place. And we have also got now 2 nodes in our HA cluster. Now, all we need to do now is go back and drop the replication slot on node 1. If you're going to revert the status and make node 1 primary once again, you might not want to do this, and instead you should be dropping the slot on node 2. But I'm going to keep it as it is, so I need to drop this replication slot. And this is it. If you don't do this, what would happen is, since there is no downstream server for node 1 to send replication stream to, it will keep on piling up all the wall files that it is receiving from node 2, in a hope that sometime down in the future, someone using the replication slot DB server 2 would connect and try to fetch these wall files. But since that is never going to happen, it will continue to pile up all these files until it has got a disk full error. And once that stage reaches, you will not be able to do any more transactions on node 1. Though you are not doing any active transactions on node 1, node 1 will stop receiving any further replication from node 2. That means now node 2 will start piling up all the replication wall file, because it is not able to send them on the replication slot which we have configured, and hence very soon the wall directory of node 2 will get filled up. That means it will not be able to write any more transactions, and that would lead to a situation when both of your nodes are not accessible. You don't want that kind of situation, so be very, very careful when you're using replication slots. I like them because they ensure that I'm able to retain all the wall files which have been configured or which have been generated by the master node or the master database. But at the same time, you have to be very careful and ensure that you don't end up putting your system in a situation where it doesn't have it is using a replication slot, or it is catering to a replication slot which is not consumed by anyone. Now, the fallback plan here would be to apply the old patch once again. I should be having binaries. Now let me just go back here, and let's say the patches did not work for me. All I need to do now is apply the old binary once again. So this is my fallback plan. I can simply apply the old binary again. I don't need to do any kind of data unload or reload. And that is how simple it is to roll back a patch in PostgreSQL. Let me just check the version once when it finishes. As you can see, the version has been reverted back to 9.5 now. Now you can follow the same procedure, apply it, you know, on the master first and then on the standby. But when you're rolling back, make sure that you stop the cluster and you get a proper downtime and then apply the patch. And since you can't afford to do this in production, that is why it is very important that you test your real test scenarios in the test environment with the new patch. And that is why it is very important. Takes me back to the same slide again, where I said you should be testing again and again as much as possible. So thanks a lot for watching our video and being part of this Hangout. If you have more queries about how to set up a HA environment or how to set up a highly available Postgres where you can do this kind of patching, you can visit one of our past Hangouts where we have talked about how you can set up a highly available Postgres database. You can go to our YouTube channel and check out our videos. This was more about how to apply patches or minor version upgrades. But if you are looking for major version upgrades, you can use PG upgrade utility to do that upgrade. You can also do a near zero downtime upgrade, but that requires a logical replication. If you want to check out PG upgrade, we have done a video on that as well, and that would be present in our YouTube channel, in the gallery of our YouTube channel. Go ahead and check it out. If you have any questions after watching this video, after going through this video, please put it up in the comments. And if you have any suggestions or any feedbacks for us in terms of what topics you would want to hear in the Hangout, or what other things that you would want to listen to, please write to us on success@ashnik.com. You can also put your queries in the comments. Thanks a lot.